youngsters. New topic today is advanced ratio problems. These are definitely questions in like the A-star level range. So if you don't feel comfortable doing these, don't worry about it too much. Just make sure you have the basic ratio concepts down. Let's get started. The ratio of boys to girls in the classroom was 3 to 4. 10 boys were added to the class. The ratio of boys to girls is now 5 to 4. Work out the number of boys in the class now. Okay, I'm just going to go line by line and draw out each part of the sentence. The ratio of boys to girls in the classroom was 3 to 4. That's pretty easy to draw out. Let's just draw out our units. So boys to girls, 3 to 4. 1, 2, 3. So for every 3 boys, there are 4 girls. Or there are 4 units of boys and 3 units of girls. Next, 10 boys were added to the class. So we're going to plus 10 to the boys section. And now, the ratio of boys to girls is now 5 to 4. So our new ratio is 5 to 4. So now, since each unit's the same size, let's call them all x. So let's write down an expression for the boys now. So x plus x plus x is 3x. 3x plus 10. So that's an expression for the number of boys now. 3x plus 10. And an expression for the number of girls is 4x. Okay? And we know now that the ratio of boys to girls is 5 to 4. So remember guys, you can always turn ratios into fractions. So we're going to turn this expression, 3x plus 10, to 4x into a fraction. And we can turn 4 into a fraction, 5 to 4. And now these two fractions are equal to each other, okay? Because 3x plus 10 over 4x gives us a ratio equal to 5 over 4. Now, if you ever have two fractions which are equal to each other, you can do something called cross multiplication. This side times this side will always be equal to this side times this side. So 3x plus 10 times 4, so we'll write that out. 4 times 3x plus 10 will be equal to 4x times 5. Let's expand the brackets. 4 times 3x is 12x. 4 times 10 is positive 40. 4x times 5 is 20x. Okay, there's unknowns on both sides. Let's get rid of one of them. I'm going to get rid of the smaller one. So I'm going to subtract 12x. Subtract 12x. Boom. 40 is equal to 20x minus 12x is 8x. 8 times something is 40. Well, x must be 5. 8 times 5 is 40. So we know x is 5. Boom, 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 boom. So, how many boys were there originally? Well, 5, 5, 5 is 15. And then we added 10 more boys. So there's 25 boys now. Okay? And that's how we solve this problem. Question now. In a jar of sweets, the ratio of blue sweets to red sweets is 5 to 9. James added 7 blue sweets to the bag and 3 red sweets to the bag. The ratio of blue to red sweets is now 9 to 16. How many sweets are there in total in the bag now? Okay, so originally the ratio of blue to red sweets was 5 to 9. Let's draw that out. Blue to red. 5 to 9. So 5 units for the blue and 9 for the red. Now, what did James do? He added 7 blue sweets. So we're going to add 7 to this section and 3 red sweets. And now the new ratio of blue to red sweets is 9 to 16. So blue to red. The new ratio is 9 to 16. Now, since each unit is the same size, we can call them all x. It's a lot of x's. Boom, 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 boom. So let's write an expression for this. X plus x plus x plus x plus x is 5x plus 7. I'll do it in a different color. And an expression for the red sweets is 9x plus 3. And we know that this, if we were to turn this ratio into a fraction, it would be 5x plus 7 over 9x plus 3. This now gives us a ratio of 9 to 16, which we can also turn into a ratio, 9 over 16. So 5x plus 7 over 9x plus 3 is equal to 9 over 16. Ooh, we have two fractions which are equal to each other. We can cross multiply. So this times this is going to be equal to this times this. So 9 times 9x plus 3 is equal to 16 times 5x plus 7. Let's expand the brackets. 9 times 9x is 81x. 9 times 3 is 27. Positive 27 is equal to 16 times 5x is 80x. 16 times 7 is, I don't even know, 112. Next, we have two unknowns on both sides. Let's get rid of one of them. I'll get rid of the smaller one. So I'm going to subtract 80x on both sides. 81x minus 80x is x, plus 27 equals, that cancels out, 112. X plus 27 is 112. We'll get rid of the plus 27 by minusing 27 on both sides. So that cancels out. X is equal to 112 minus 27 is 85. So we now know x was 85. I'm not bothered to write 85 for all of those, but just because I love my students, I'll do it. And then the question is, how many sweets are there in total in the bag now? So for the blue sweets, there's going to be 85 times 5. And we added 7 more. So 85 times 5 is 425. And we added 7 more sweets. So we add 7 to that. So it's going to be 432. And then for the red sweets, it's going to be 85 times 9. So it's 765. And we added 3 to that. So it's going to be 768. So there are now 432 blue sweets, 700, and for red sweets, there's 768. So in total, we'll just add those up. 768 plus 432 is 1,200 sweets. And that is your final answer. Guys, here are some practice questions very similar to the questions we just covered just now. And next, we'll do some other style of problems. All right, guys, next style of question. At a safari park, the ratio of lions to tigers is 7 to 4. The ratio of elephants to tigers is 1 to 2. Write down the ratio of lions to tigers to elephants. Okay, let's go sentence by sentence and let's illustrate. At a safari park, the ratio of lions to tigers is 7 to 4. So lions to tigers is 7 to 4. And the ratio of elephants to tigers is 1 to 2. Write down the ratio of lions to tigers to elephants. Okay, so what I like doing is I like to combine both these ratios into one little chart over here. So what do we know? The ratio of lions to tigers is 7 to 4. So 7 to 4. And we know the ratio of elephants to tigers is 1 to 2. And I'll put that below. 1 to 2. Now, since we have a value for the tigers, we're going to use the tigers to help us. And what we're going to do, guys, really straightforward, is you're going to find the lowest common multiple of 4 and 2. So what's the first number that appears in both the 4 times table and the 2 times table? Well, it's easily 4. So we want our tiger unit to be 4. So let's start with the first ratio. Fortunately for us, we want our tiger unit to be 4, and our tiger unit is already 4. So our lions can just stay the same, 7 lions. But how about the second ratio? Our tiger unit is 2. We want our tiger unit to be 4. How do we get from 2 to 4? Well, we just times by 2. So what do you do to the elephants? You times it by 2. And this is your answer, guys. The ratio of lions to tigers to elephants is 7 to 4 to 2. In a box, there are white, milk, and dark chocolates. The ratio of white to milk is 3 to 5. The ratio of milk to dark is 8 to 1. What fraction of the chocolates are white chocolate? Okay, let's illustrate this. So, what do we know? Well, I know the first ratio, the ratio of white to milk is 3 to 5. So let's write that down. White to milk is 3 to 5. And the ratio of milk to dark is 8 to 1. And our goal is to find what fraction of the chocolates are white chocolates. Okay, well, since I have 3 different chocolates, white, milk, and dark, let's create a ratio involving all 3 types of chocolates. So white, milk, and dark. Now let's fill it out. So we know the ratio between white and milk is 3 to 5, so 3 to 5. And then we know the ratio between milk and dark is 8 to 1. Now, since we have a value for the milks in both ratios, so we're going to find the lowest common multiple of 8 to 5, of 8 and 5. So what's the lowest common multiple of 5 and 8? What's the first number that appears in common in both those times tables? Well, it's 40. So our milk value will be 40. So let's look at our first ratio. Our milk value is 5, but we want 40. How do we get from 5 to 40? We times by 8. So if we times this by 8, we have to times our white chocolate value by 8. So 3 times 8 is 24. Now, let's look at our second ratio. If our milk value is 8, and we want our milk value to be 40, how do you get from 8 to 40? You times by 5. So what do you do to the dark chocolate value? You also times by 5. 1 times 5 is 5. So that's the ratio between the white chocolates, the milk chocolates, and the dark chocolates. Now let's answer the question. What fraction of the chocolates are white chocolates? Well, we have 24 units of white chocolates out of how many units in total? 24 plus 40 is 64. 64 plus 5 is 69. Nice. And that is the fraction of chocolates which are white. Alright guys, a final question. In a drawer there are white, black, and gray socks. The ratio of white socks to black socks is 3 to 2. The ratio of white socks to gray socks is 9 to 4. Write down the ratio of white socks to black socks to gray socks. Okay, let's digest this information. In a drawer there are white, black, and gray socks. The ratio of white socks to black socks is 3 to 2. Let's write that down. White socks to black socks is 3 to 2. The ratio of white socks to gray socks is 9 to 4. White socks to gray socks is 9 to 4. Write down the ratio of white to black to gray socks. White to black to gray socks. So let's add both these ratios to our chart over here. So white to black is 3 to 2. And then white to gray is 9 to 4. So since we have whites in common, we're going to find the lowest common multiple of the white sock. So lowest common multiple of 3 and 4. Lowest common multiple of 3 and 9. What's the lowest common multiple of 3 and 9? Well, the first number that appears in both those times tables is 9. So that's going to be our white sock value. Let's look at the first ratio. How do I get from 3 to 9? Well, I times by 3. So I got to times this ratio by this unit by 3. 2 times 3 is 6. Now let's look at the second ratio. How do I get from 9 to 9? Well, yeah, times by 1. So I have to times this by 1. So you're not really changing anything. 4 times 1 will be 4. And that's the ratio of white socks to black socks to gray socks. Okay? Now, in part B, that's our answer to part A. LC says there's an odd white sock. Explain why LC might be wrong. Okay, so let's look at this ratio and let's interpret it. So our ratio we found between white, black, and gray socks was 9, 6, and 4. So let's write a sentence about that in terms of socks. So for every 9 white socks, there are 6 blue socks, black socks, sorry, and 4 gray socks. Now, LC says there's an odd white sock. Explain why LC might be wrong. Well, remember guys, just because the ratio is 9 to 6 to 4, it doesn't just mean there are 9 white socks, 6 black socks, and 4 gray socks. That's just a ratio. What we could say is we could double these, all right? So 9 white socks, let's double all these values. 9 times 2 is 18 white socks, 12 black socks, and 4 gray socks. And this is a possible number of socks each LC might have. When, look, the white socks is even. But if we simplify it, yes, it'll give us a ratio of 9 to 6 to 4. But the ratio doesn't tell us how many socks there are. It just tells us the relationship between the number of socks there are. So we've just proved that there doesn't have to be an odd number of white socks. Here guys, here are some questions you can try in your own time to practice this concept.